Good morning, class. We're back with lesson 5.6. We've been doing some math review, looking at the different types of numbers we're dealing with, real versus natural, etc., 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 radical. Now we're moving on to exponents. Exponents and scientific notation. So you've probably seen these before, but we're going to do a quick review, and hopefully if you haven't seen them before, it makes sense. When we talk about exponents, we're actually talking about powers of numbers. And as we look at powers, here's an example: 4 to the power of 2, also read as 4 squared. When we write this out, it's going to be basically like 4 times 4. The 2 means that we're multiplying 2 4s together. Calculate it out, we get 16. Another example here: if I have -5, and again, parentheses are important. You're going to hear me say that a couple times. But if I have -5 squared, this is technically -5 times -5, which is a positive 25. One more example: 5 cubed, 5 to the power of 3, is 5 times 5 times 5, and that comes down to 125. 5 cubed, 125. As we look at these powers, we can also get some real big ones, like 1 to the 1,000th. Yo, that is 1 times 1 times 1 ... 1,000 times. Well, the cool thing is we know that that's going to wind up being 1. All right. Another special circumstance: 7 to the power of 1. Well, that's just 7 times nothing. 1 is by itself. So that's 7. Okay. Looking at evaluating powers, a couple of your examples, you're going to have to do this, evaluate them out. Remember, parentheses matter. We have to be very careful with our parentheses. If we have -3 to the 4th, we can think of that as -1 times 3 to the 4th. So when you see a negative symbol out front without any special parentheses or anything, we're going to solve it as though the number is a positive and just pull that negative off for a moment. So we'd solve this as -1 times 3 times 3 times 3 times 3 times 3, giving us -1 times 81, which is -81. Very different from this little buddy. -3 in parentheses to the 4th. Well, that we will write out as -3 times -3 times -3 times -3. Parentheses matter, and we get 81 when we break that down. So that's how you evaluate exponents. Hopefully it was review-ish. If not, please do take some time to reread that section. But let's move on to our rules of exponents. And I've got this little copy and paste diagram, same one as in your homework. But laws of exponents, as we look at the laws of exponents, we're going to talk about 6 of these guys. Not all of them. I think 6 of them. We're going to start with the product property of exponents. So when multiplying like bases, you add the exponents. So when we talk about bases, that is the big number, the number underneath. That's called the base. So in this example, we have base A and A. So since we have the same base, we can then add the exponents. So A to the M times A to the N gives us A to the M plus N. Here's an example with real numbers. Same base, they're both 5s. We have 5 cubed times 5 squared. You can really think of that as 5 times 5 times 5 times 5 times 5, which is 5 to the 5th. And when we simplify that or work it all the way down, we get 3,125. So that is a product property of exponents. Here's another generic example: x to the 4 times x to the 8th. Well, since they have the same base, this would be x to the 12, and that's as simple as that one's going to get. Quotient property of exponents. Quotient property is similar in the idea that when you are using like bases, when dividing like bases, you subtract the exponents. So if I have am divided by an, that's the same as saying a to the power of m minus n, but a has to not be equal to 0, obviously, or else this won't work. So here's the live example: 2 to the 5th divided by 2 squared. We're going to subtract 5 minus 2 to get 2 cubed. To get cubed. the 3. So we have 2 cubed, and we can actually solve that in general form. We have x to the 12 divided by x to the 7th. We subtract 12 minus 7, getting x to the 5. So that's the quotient property of exponents. Next, the zero property of exponents, or zero exponent rule. Anything to the power of 0 equals 1. Literally anything. I could even use a to the power of 0, and I'm going to get 1. I could do 125 to the power of 0. Guess what? 1. If I do x to the power of 0, oh, we got 1. So that's a pretty easy one. Just tuck that in the old brain bank. Next, we have negative exponent rule. A negative exponent takes the reciprocal of a power. Reciprocal is when we flip things over. Okay, so if we have a to the negative m, it's going to be equivalent to 1 over a to the positive m. Example here, 5 to the negative 2 is 1 over 5 squared, which is 1 over 25. 8 to the negative 1 is 1 over 8. X to the negative 7 is 1 over x to the 7. Here's a wacky one. Y cubed over y to the 5. Now, if we do our math, we're going to get y to the negative 2. Remember, we subtract top minus bottom. Well, top minus bottom leaves us with y to the negative 2. But that can be simplified down to 1 over y squared. You will have a couple examples like this on your homework. Okay, next one is power of a power property of exponents. I don't know if that's a miscue. Nope, it's not. When you take the power of a power, you multiply the exponents. So this is power of powers. So we have exponents upon exponents with parentheses to help guide us. So a to the m, and we take that a to the m to the power of n, we're multiplying the exponents. Example, 2 cubed, but then we square 2 cubed. That's going to be 2 to the power of 6, which is 64. And if you're ever unsure, you can always write these out. If I go 2 times 2 times 2, that's one of them. But then I'm squaring it. I do it again. 2 times 2 times 2, I get 2 to the power of 6. And that equates 64. Next, we have x to the power of 4 to the power of 5. That's going to be x to the 20th. Multiply 4 times 5, get 20. 3 cubed to the negative 1. Yo. Well, remember, negative exponent, we're going to flip it. We're going to put it underneath. So 3 to the negative 1, 3 times negative 1 is going to be negative 3. And now we have 1 over 3 cubed, and that will simplify down to 127. So those are the rules. I do have this little chart here on the right here linked to your homework, so you can have it up if you need to help remember. Now, there's a couple other rules on there. We aren't going to hit those in this homework assignment, but they might be helpful. All right. The second half of the assignment is scientific notation. Again, Mrs. Wendt probably worked on this with you. I know we spent a little time if you had me for life sciences, but let's talk about it. To write in scientific notation, we're going to, 1, move the decimal point to the original number to the left or right until you obtain a number greater than or equal to 1 and less than 10. Remember, scientific notation, you always have a number between 1 and 10 and then point whatever. Count the number of places you have moved the decimal point to obtain the number in step 1. If the decimal point was moved to the left, so if you go to the left, and I like to use a little thingies, the little loops, the count is to be considered positive. If the decimal point was moved to the right, the count is to be considered negative. And then we multiply the number obtained in step 1 by 10 raised to the count found in step 2. Note that the count determined in step 2 is an exponent on the base of 10. To go the other way, we observe the exponent on the 10. Then, if the exponent is positive, we move the decimal and the number to the right. Because again, if it's a positive number, we're going to get a really big number. So we're going to move our decimal to the right, adding zeros as necessary. If the exponent is negative, we take the decimal where it is and move it to the left, the number of places as the exponent, adding zeros as necessary. Here are 2 examples. Standard form, 4,300,000 in scientific notation. My decimal is here behind the 0. So I'd move it to the left 1, 2, 3, 4, 5, 6 places. That's why we get 4.3 times 10 to the 6. For 2 10,000ths, my decimal place is way over here on the left. I'm going to move it 1, 2, 3, 4 spots to the right. So that's 2 times 10 to that negative 4, since I had to move that decimal point to the right. All right. On top of this, we have a couple of special operations in multiplying and dividing scientific notation. First off, if we multiply scientific notation, we have those two numbers we had just a moment ago. We could do this. It would be interesting. However, if we whip it into scientific notation, it kind of makes it a little bit easier. So I have the numbers, 4.3 and 2, they can multiply each other. And that's going to be times 10 to the 6 times 10 to the negative 4. But we just talked about what 10 to the 6 times 10 to the negative 4. They're the same base. So that becomes 10 squared. So we have 4.3 times 2, which is 8.6, times 10 squared. In dividing, similar kind of concept. Yo, that looks really scary. However, I can turn this into 4.8 times 10 to the negative 11. I'm moving this decimal to the right 11 spots over 2.4 times 10 to the 10. So I'm moving that decimal to the left 10 spots. And now I can do the same thing I did in the other spot. I take 4.8 divided by 2.4, and I'm multiplying all that by 10 to the negative 11 over 10, 10. So that's going to give me 2 times 10 to the negative 21 as my final answer. Follow the same rules. However, when doing scientific notation, we can pull out the numbers that we have away from the exponents and solve them separately. Here's a quick word problem. You're going to have a couple of these word problems coming up on the homework as well. August 28th of 99, the U.S. Department of Treasury said the debt was about 5.65 trillion. I didn't look it up to see what it is now, but I'm scared to see it's probably higher. On the same day, the consensus estimated about 273 million people in the U.S. How much average debt per person? Yo. So if we have 5.65 trillion over 273 million, we can write that out as 5.65 times 10 to the 12 over 2.73 times 10 to the 8. We then use our skills. 5.65 divided by 2.73 times 10 to the 12 divided by 10 to the 8. We're going to get 2.07 times 10 to the 4. That is about $20,700 per person. That is a lot of money. And like I said, I bet you today's day, probably a little higher. Sorry, kids. Anywho, homework. Got to have some homework. Read these pages to review the homework and the problems. Your actual homework assignment is on those pages, 234, 236. And I was trying to get you about 3 or 4 examples from each of the different sections, so you're welcome. A couple of the end ones are word problems, so take your time. If you get stuck on a word problem, please let me know. Remember, you want to try to find the most important content before you send it. So that's all I got for you today. We'll see you in class.